Hi everybody, welcome to this next video. So we're going to look in this one about factorising and solving quadratics. So we're looking here at when x squared is just 1. In the second part of the video we'll look at factorising harder quadratics when the x squared value is greater than 1. So this will also be on foundation, so it's worth foundation and higher just checking through this. So let's talk first of all about the factorising process. So here what I'm looking for is I'm looking for two numbers that add to give me 9 and multiply to give me 20. So if you're ever not sure on which way round that is, think about it alphabetically. It goes AM, like the morning, it's in the AM. So add to 9, multiply to 20. That can be quite a good way to remember it. So what I would suggest you do here is you do your 20 times, your factors of 20. So you say, well, 1 times 20, 2 times 10, 3 doesn't go into it, 4 times 5, 6 doesn't go into it, 7 doesn't go into it, 8 doesn't go into it, 9 doesn't go into it, and I've already done 10, so I can stop. So then from here, what you're looking at is what pairs out of these three, what pairs could you possibly use to make 9? And the answer here would be 4 and 5, because 4 plus 5 makes 9. Now I know this one's a little bit easier because they're both positive, so I don't need to think about any negative numbers involved. And then what you do is you open up your two sets of brackets, you put an x in both, and you put plus 4, and then you put plus 5, and that is now factorised. Remembering that factorise means put back into brackets, okay? You can identify that this is a quadratic because what you're thinking about is the fact it's got an x squared in it, it's got an x value, and it has also got a number, so there are 3 parts to it. There are some variations on this, but I'll explain those a little bit later on. Okay, so now moving on to how we then solve that. So I already know that I'm looking for two numbers that add to 9 and multiply to 20, so I could go through the same process again, but I've already done it, so I'm going to use that information. So I know that it's x plus 4 and x plus 5. And now because this equals 0, this is the key thing to solve in a quadratic. It must equal 0. If it doesn't equal 0, you have to make it equal 0 by rearranging any values on that other side. But because this already equals 0, I can just factorise straight away. You then say x plus 4 is equal to 0. Or x plus 5 is equal to 0. So what I'm doing there is I'm saying this bracket here is equal to 0 and this bracket here is equal to 0. With a quadratic, if you are solving it, you will have 2 answers. From this point, remember that solve just means find x. So you take the plus 4 and move it over, and it becomes x is equal to minus 4. Or, there's your plus 5, move that over, x is equal to minus 5. So that is now a quadratic that has been factorised. So because it's something adds to 9 and multiplies to 20, I can factorise it, and then it equals 0. That means I can solve it. It couldn't be factorised. There are alternative ways to solve it. If you look at the videos on solving quadratics by completing the square or solving quadratics by the quadratic formula, they will help you. What I suggest you do now is pause the video, have a go at these bottom 2 to make sure you can get your head around it. Be careful because they've got a negative involved. See if you can figure that out. Pause the video and then I'll go through it in a second. Okay, so let's go through these bottom 2 then to make sure you're happy with the process. So again, we're looking at here, we need two numbers that add to give me minus 10 and multiply to give me plus 16. What we need to be careful of is the fact that this is now a negative. So thinking about what multiplies to 16. So 1 times 16, 2 times 8, 3 doesn't go into it, 4 times 4, and then I can stop there. Nothing else goes into 16. What I need to think about is out of these factor pairs, how can I possibly make a 10? Now, the two numbers I can actually use to make a 10 are 2 and 8. So I know it's going to be x in both, and I know it's going to be 8 and a 2, but I need to think about how can I possibly make minus 10. So this is where your knowledge of negative numbers comes in. So in order for me to make a minus 10, I know I need a minus 8 and a minus 2. That's the only way I could possibly make minus 10. And then if you think about it logically, minus 8 times minus 2, a negative times a negative gives you a positive, which is how I end up with the plus 16. So still do your factor pairs like we've done at the side here. Then figure out of those, how can I possibly make 10? Well, I can't make a 10 out of 1 and 16. What I could make is a 15 or a 17. Out of 2 and 8, I know I can make a 10. And out of 4 and 4, I'd either make an 8 or a 0. If I added them together, I'd make 8. If I did one as a positive, one as a negative, I'd make a 0. So it has to be these two. From here, what you're then doing is you're putting them both into brackets. So x minus 8 equals 0, or x minus 2 equals 0. And then from there, we go through our solving process like we've just done. The plus 8 moves over this side and it becomes x is equal to, sorry, the minus 8 moves over and it becomes a plus 8, or x is equal to, that minus 2 goes over and becomes a plus 2. So they are your two solutions. Remember, with a quadratic, there are two possible solutions. Okay, let's now look at what happens when there's an x squared that is greater than 1. And this is what I mean here, when x squared is greater than 1. So if you look at this, this is now a 2x squared. This would be on higher. So for those of you sitting higher, this is what you need to be able to do. If you're on foundation, you wouldn't need to worry about doing this. So I'm going to show you a shortcut, basically, a quick way of doing this to make it a little bit easier for yourself. But I'm going to label it A, B and C, and the reason I'm labelling it A, B and C is just so I can describe what we're doing a bit easier. But also, if you label it A, B and C, that's what you would use in the quadratic formula to solve as well, so it links into that. Now, the first thing you do is you take your A value, which in this case is 2, and you multiply it by your C value. So I'm doing 2 times by 35, which is equal to 70. You are including the sign in here as well, so if that was a minus 35, it'd be minus 70. What I now need is two numbers that multiply to 70, but add, so this bit still stays the same, we add to this middle B value here. So add to 19, and that's a plus 19, and multiply to give me 70. So you've got to think about what two numbers it could possibly be. So let's go through our 70 times tables again. So 1 times 70, 2 times 35, 3 doesn't go into 70, 4 doesn't go into 70, 5 does go into 70, and it's 5 times 14, 6 doesn't go into it, and then 7 times 10. So I still go through my factor pairs, recapping the factor skills that I need as well. And looking at that, which one of those pairs could I possibly use to make a 19? So let me just quickly recap what we've done. We've taken out A value, which is a 2, multiplied it by our C value, which is 35, to get 70. So you now need two numbers that add to this middle value still, but multiply now to this 70, not to 35. So I've done my factors of 70 down the side here. And the two numbers that it's going to be have to be 5 and 14, because there's no other way to make 19 out of all those numbers. What we then do is a shortcut, okay? So your shortcut here, because this has got a 2x in front of it, what you do is you put 2x in both brackets. From there, you then take both your factor pairs, so 5 and 14, and they are both positive numbers here because I'm making plus 19, and you put them both into the brackets. Now, those of you that will be looking at that thinking, well, that can't work, because 2x times 2, if I was to expand this out, 2x times 2x gives me 4x squared, and I only need a 2x squared. But what you should be able to find, if you've done this correctly, is that one of your brackets will simplify. Now this one divides by 2. The one on the left doesn't divide. So I leave this one as 2x plus 5. And then the right hand one, divide by 2, becomes x plus 7. And that is now factorised. So that is a shortcut on how to do it. If there was a 3x, for example, at the start here, like we've got here, you'd put 3x in both brackets instead of a 2x in both brackets. And that's how you'd factorise when x squared is greater than 1. So now let's look at what happens when we're solving. So I've already gone through the process of factorising here. So we're saying 2x plus 5 and x plus 7 is equal to 0. So same as the process we've done in the previous part, we now say 2x plus 5 is equal to 0, or x plus 7 is equal to 0. And from here you are solving, so you're getting x on its own. So let's start on this right hand side here. The plus 7 goes over and it becomes x is equal to minus 7. The plus 5 goes over here. And what we now have is 2x is equal to minus 5. But I've got to do an additional step here. I need to get rid of this 2. So because that's a times by 2, when I move it over, it becomes a divide by 2. So my answer becomes x is equal to minus 5 divided by 2. Or you could put that as minus 2.5. It doesn't matter. So that's how you solve. Okay, what you can do now is pause the video again. Have another go at these bottom two. See if you can follow the methods I've just done. If you need to go back and watch the video again, do so. And see if you can figure out the process yourself and have a go answering the bottom two. Okay, here we go. So A value times by my C value. So 3 times by 12 gives you 36. So I need two numbers that multiply to 36, but add to 13. So let's go through our 36 factors of 36. 1 times 36, 2 times by 18, 3 times by 12, 4 times 9, 5 doesn't go into it, 6 does go into it, 6 times 6, and I can stop there because I've hit the same number, and we know that they are all our factor pairs of 36. Now, looking at this, I need to figure out how can I possibly make 13 out of these numbers. So can't make 13 out of that, can't make 13 out of that, can't make 13 out of that, but I can make 13 out of 4 and 9. So these are my factor pairs. So you then go, right, let's put 3x in both brackets. So 3x goes in both, plus 4 in one and plus 9 in the other. And then again, as I said in the previous one, this one on the left-hand side doesn't factorise. Doesn't divide, doesn't simplify, so it stays as 3x plus 4. But you'll notice this one on the right-hand side can divide by 3. So it becomes x plus 3. And that is now factorised for you. Okay, so looking at that, what we can do is go on to the solving part. So if it was equal to 0, we're saying 3x plus 4. And then x plus 3 is equal to 0. So 3x plus 4 is equal to 0, or x plus 3 is equal to 0. From here, you then take the plus 4 over the other side, and it becomes 3x is equal to minus 4. And then because it's a times by 3, I need to divide by 3. So x is equal to minus 4 divided by 3. Okay, or you could leave that as a decimal, 1.3 reoccurring. And on the right hand side here, we are saying the plus 3 goes over, so x is equal to minus 3. They are your two solutions to that. Okay, so go through that process again if you're not 100% sure. Watch the video again. Just remember you do your a value times your c value first, and that's your multiplier. So you need numbers that multiply to that and then add to your b value, which is the middle section. Okay, hope you enjoyed the video, and I'll see you in the next one.